Hi everybody. So today we are going to start with the law, which is the last one, the law of reciprocal proportions. And in this video we are going to consider one more thing, which is the hypothesis of Berzelius and the Avogadro. So what was the difference between their hypothesis, who was right, who was wrong, that also we are going to cover in this video along with the law of reciprocal proportions. So what this law tells, okay, so the definition of this law is too long, so and it's of no meaning. I will tell you some examples by which you can understand uh, what the law means to say. So let's take three compounds: H2O, CH4 and CO2. Now let's analyze the ratio of C is to O in the CO2 by mass. Okay, so what is the mass of carbon? It's 12. What is the mass of oxygen? Twice, because it's O2, so it's 32. So the combining ratio is 3. Oh, 1 minute. Okay, leave it. 3 is to 8. I am talking about C is to O. Okay, and now let's analyze these two compounds. Let's see the ratio of oxygen is to hydrogen and carbon is to hydrogen here. Okay, so for 16 grams of oxygen, there's 2 grams of hydrogen. So for 8 grams, means 1 gram of hydrogen, there's 8 grams of oxygen. Agree? Yeah. So for 12, in the case of CH, for 12 gram of carbon, there is 4 gram of hydrogen. For 1 gram of hydrogen, there is 3 gram of oxygen, 3 gram of carbon. Okay, so what do you observe here? Observe these two values. So we observe here, when we are taking any compound, its ratio, if it is common, like for example with an X compound, its ratio is X is to Y. So when it combines with some another compound, its ratio will remain in multiple proportions of it. It will not be exact, but this is an exact case, but it will remain multiple proportions of it. Okay, so see, 1 gram of hydrogen, at both cases 1 and 1 gram is there. So if this is there, like this case is there, like at both sides, the ratio is 1 and 1 of a particular fixed compound which we are taking. Here that particular fixed compound is H. So at that case, if the particular fixed compound is at same ratio in both the cases, when the compound of the adjacent will form, their ratio will be fixed, which will be here in this case it will be 3:8. If we see the ratio of, here we are taking C is to O, so here also we will take C is to O. If you take O is to C, then it will become 8:3. Okay, so this is told by an law, so we can know. But like if they have given us compound, suppose let's take the same example, CH4 and H2O, and they have asked us that what will be happening when these two compounds get mixed. So the compound can be CO, it can be CO2. These are the major two cases. So the ratio of oxygen will not be always. Like here we were taking the case of CO2, so I told that they are in multiple proportions, so the ratio here will not be exactly 3:8. No, here the ratio will be 3 is to multiple of 8, which is 1 by second multiple. Okay, so we can take such cases where the multiples are half, like that, or we can say 8 is the multiple of 4. That will be more convenient. So